This is the sensor board from Microbit from MonkMake. I've linked below where you can buy it, a couple of different places. It's got 3 built-in sensors. It's got a sound sensor, a temperature sensor and a light sensor. These 3 sensors are all analog based, so we can read them from the Microbit quite easily. We've got a 3V and ground connection here, and we've also got a 3V and ground connection here. And that's unusual, but what it allows us to do is to daisy chain another device on here. So if we want to add a speaker, we can power it and ground it from this device. So we're going to look at each of the individual sensors one at a time, and we'll have a look at some code and we'll get you up and running with this sensor. So wiring up our sensor is relatively straightforward. We have to connect the 3V, the ground, and whichever one of the sensors we want, or multiple sensors. So each sensor is obviously going to go to one of the data pins 0, 1 or 2 on the Microbit. So we'll go ahead and wire up one just to show you what it looks like. Okay, so now I've wired up the sound sensor. I have 2 free ports on the Microbit, 1 and 2, and I could use those if I wish to wire up the temperature and light sensor. On the sensor, I've used the left hand side 3V and ground, but I could just as easily have used the right hand side 3V and ground. So now I'm ready to write some code and test the sensors. Coding the light sensor is quite straightforward. This particular light sensor works on a scale of 0 to 900, with 0 being complete darkness and 900 being the top limit of light that it can sense. So to make sense of some of those levels, what we can do is we can use maybe a graph, which is easier to read than maybe just some arbitrary number. So the first thing I'm going to do is create a variable called reading. This variable is going to take the raw input from the port. At this point, we now have that number between 0 and 900. So what we're going to do is I'm going to create a simple graph. Because I know 900 is the upper limit of the graph, that's what I'm going to put in here. Now we're ready to test the sensor. So demonstrating the light sensor using a little graph on the Microbit. If I put a light over it, we can see the graph reacting to the amount of light. It's pretty cool. It seems to be pretty real time. So the pins on our Microbit are capable of reading different voltages from 0 volts all the way up to 3.3 volts. So in the middle you've got about 1.5 volts, just approximately. So how can we use these different voltages to represent data? Well, what we can do is we can set that as our top limit and set that as our bottom limit. And this is going to be our middle limit. And we can split up these voltages between normal numbers. So if we say the first baseline is going to be 0, and if we count all the way up to 1023, so that gives us 1024 different levels including 0. So in other words, on our Microbit we can read from a sensor anything from 0 up to 1024 different items can be represented by splitting up this spectrum of voltage. So for example, if we want to send in a level of 512, which would be in and around the middle, we would put in 1.5 volts into the pin of the Microbit, and that would represent 512. If we were to put in 3 volts, that's probably in and around here somewhere. So that might be representing maybe 950 or something like that. So that's how we do it. And by using different numbers and sending different signals, what we can do is we can create an analog signal. So an analog signal of up to 1024 different levels, and when the Microbit puts them all together, it can form the waves. So you might split up a sound wave into 0 to 1023. So that's just a quick overview of how it works, and I suppose it's just keeping these numbers in mind is what we'd be dealing with. This is more behind the scenes, whereas these are the actual levels we'll be dealing with in our code. So given what we now know about Microbit reading analog data from its ports, let's have a look at how the sound sensor works. So the sound sensor again is going to give you a number between 0 and 1023. The issue with this sound sensor is that it reads a 0 at about 1.5 volts. So if there's no noise, if there's silence, it'll be in and around that. Once there's noise, it oscillates up and down, like so, and continues. Now of course, if this is the silence cutoff, anything below this is not really of any interest to us. So really what we want to do is we want to gather any information from 512 to 1023. So what we're going to do is, when it comes to coding this sensor, we're going to take in whatever we read and we're going to take 512 away from it. So in other words, we're going to make this our baseline and make this our top end, well, except it's going to be down to 512. So we're really going to transfer the number 0 up to there and 512 up to there, and this is the only part of the data that we are interested in reading, because everything below that is technically silence. So once we understand how the sound sensor works, it's quite easy to code. So again, I've set up a variable called reading. I've set it to read from the analog pin 0, and we've put that in a forever loop. So all that's left to do now is to adjust the maths of it. So we're going to take away 512 from that reading. Once again, I'm going to make a graph of this information because, again, it's easier to read than some arbitrary number. Again, I'm going to set the limit of the graph to 512. Let's go and test our code. So demonstrating the sound sensor, you can see it oscillating here with my voice. It's still pretty low, but if we play some music, we might be able to get it up a little bit higher. I don't like doing it, but we're going to skip over some of the detail behind the temperature sensor. So I'm going to go directly and show you the math we need to use to calculate the temperature in degrees Celsius. So as we're reading it into pin 1 from the temperature sensor, this is what we're going to do to that reading. So whatever raw data is coming up, we're going to take that reading and we're going to multiply it by 75. We're going to get our answer and divide that by 1000. And when we get the answer to that, we're going to subtract 14. Again, I don't want to go into too much detail behind the reasoning, it's just the way this particular sensor works, and this is how we're going to calculate our temperature. Of course, if you want your temperature in degrees Fahrenheit, you've got a little bit more work to do. The temperature data, as we've just seen, requires a little bit of maths to be done, but I read it in the same as I've read in all the other data. I've created a new variable called temperature, and in here I'm going to do the little bit of math. To begin with, I multiply by 75. I divide that solution by 1000. And finally, I minus 14. In this case, I'm just going to display the temperature to the screen. And now we're ready to test the code. So you can see our temperature demo is now running. It scrolls the temperature across the screen as it reads it. So right now it's reading 22.98 degrees. So let's see if I can manually warm it up. I place my finger over the center. Here I'm demonstrating how another device, the speaker, can be daisy-chained through the power connections of the sensor board to create one system. So I've connected the light sensor back to the microbit, and I've connected the speaker also back to the microbit, but it's powered through the sensor board. So again, I'll put the code on the screen that I'm using for this simple demonstration, but when I shine a bright light onto the light sensor, we should hear the speaker being triggered. And there you go, a simple way of connecting devices.